This is a flip video about solubility curves and how to solve problems. If we take a look at our graph here, this is an example of a solubility curve. It's a graph that has many different substances on it, and if you read the axes, so let me kind of move the axes up a little bit so you can see, we've got temperature in degrees Celsius on our x-axis, and on our y-axis, something a little unique, grams of solute per 100 grams of water. So I'm going to talk about that in a second, what that means, but now we know what our axes are. And if you notice, I've got different solutes: sodium nitrate, potassium nitrate, sodium chloride, and SO2. There's something unique about SO2 that you should note. SO2 is a gas, while all the rest of the lines on here, the blue, black, and red, are solids. So notice the trend. Okay, now, what does this graph show? Well, it shows, again, like we said, the solubility of solids and gases. And what is solubility? Well, if you remember, solubility is the amount of solute that dissolves in a certain amount of solvent to create a saturated solution. So going back to our curves, all of these lines on our curve represent saturation points. Saturated solution, saturated solution, saturated, saturated. Okay? So the last thing we should note, seen down here, is that clearly the amount of solute that can dissolve depends on the temperature. So if we go back to our graph, if we notice and we look at sodium nitrate, for example, as the temperature starts to increase, more and more and more solute can dissolve. Okay? All right, so like I had mentioned before, I'm going to talk about the axes right now and what they mean. We know what temperature means, but what does this y-axis mean over here? Well, the y-axis says that it's the grams of solute per 100 grams of water. So what this means is that if we take a look at this beaker and we pretend that we've got water in here and there's 100 grams of water. Remember, 100 grams is the same thing as saying 100 milliliters of water. This is how much solute can dissolve in 100 milliliters of water to make a saturated solution. That's what this graph shows us. Is it says, do you want to know how much NaNO3 can dissolve to make a saturated solution at, let's say, 25 degrees Celsius? I take my 25, I run it up until I hit the line, and then I look across and I read, right? So somewhere around 90, right? Maybe we'll say 95. 95 grams of solute dissolves in 100 grams of water at 25 degrees Celsius. So this just tells us how many grams of solute is dissolving in our beaker full of 100 grams of water. So all of these curves pretend like all of these solutes are in their own individual beaker of 100 milliliters of water, which is the same thing as 100 grams of water. Okay? Okay. Next, let's take a look at what the lines basically mean again. If we're talking about points on the line, then we've created a saturated solution. That means the maximum amount of solute that can dissolve in the solvent at that temperature. What if we're talking about below the lines? Well, if I'm talking about anything below, let's say this blue line, then that's unsaturated for sodium nitrate. How about above the line, points above the line? Well, sometimes people think that means supersaturated, but that's not true. Above the line is just still saturated. That just means I'm going to have a lot more solute sitting at the bottom of my test tube or my beaker. Okay? So, we can get a lot of information from this graph. Okay, let's look at some more trends that we see. Now, all the solid solutes, as I mentioned earlier, are sodium nitrate, potassium nitrate, and sodium chloride. Your graph might have a ton more, but I've just pulled out a few. So let's focus on our solid solutes. As you just noticed, all the solid solute lines on the graph are going up in a positive slope. This one not as much, a little bit more gradual. Okay? So all positive slopes. What does that mean? Well, that means that the temperature, as the temperature increases, more solid solute can dissolve. Okay? As I increase the temperature from 0 to 100, look how much more solute can dissolve. Okay? Well, what does it mean when my lines are steep versus gradual, seen here? Gradual means that not much change is happening. It means that as I increase the temperature, I really can only dissolve very little more solute. Whereas when the line's extremely steep, seen in these, it means that changing the temperature really affects how much solute can dissolve. Okay? At a low temperature, around 25, I only have about 30 grams that can dissolve. But somewhere around, 75 or even 60, I can dissolve a lot more solute. Okay? All right, so that's for solid solutes. How about the gas that we saw on here? If you remember, we've got the gas going down here, seen in green. Well, that's an opposite line. And so on the graph, if you notice, right, it's going to have a downward slope, which means the opposite's sort of happening, right? As temperature increases, the amount of that gas, SO2, the amount of gas solute decreases. So that means as I increase temperature, not as much gas will dissolve. This is an opposite effect compared to the solid solutes. Why is that the case? Well, let's think about what happens when gases get warmer, okay? So if you notice here, I've got a very warm gas over here, right? At 75 degrees Celsius, that's very warm. Very little very little solute, SO2 is the solute, it's a gas, dissolves, okay? So my gas solute, right, my gas solute doesn't dissolve much at high temperatures. Why? Because as the gas temperature increases, what happens to the kinetic energy of a gas? It also increases. So that means at a high temperature, this gas is moving around really fast. Well, if the gas is moving around really fast, is it going to want to stay inside the water? No. It's going to want to move up. And so if it moves up out of the water, does it dissolve? No. So that's why at high temperatures, gases, right, are not very soluble. They don't dissolve because they're moving around very fast as much compared to a solid. Okay, let's look at some sample problems. Here's an easy one. It says at 10 degrees Celsius, how much solute can dissolve in 100 grams of water for NaNO3? Okay, now, as long as they mention 100 grams of water or 100 milliliters of water, this means I can use this graph. Why? Because look at the axes. It talks about grams of solute per 100 grams of water. That's all this means. So don't let this interfere in any calculation or anything other than allowing you to use this graph. Okay? So now I'm going to find NaNO3, it's the blue line, and 10 degrees Celsius, right? 10 degrees Celsius is somewhere around here. So now that I know where 10 degrees Celsius is, seen around over here, I run that line all the way up to my NaNO3 curve, and then I read across to see how many grams that is. At 10 degrees Celsius, 80 grams will dissolve because it hits the line right there. So the answer is 80 grams. Okay, so let's look at a slightly harder problem. How much NaNO3 will dissolve at 10 degrees Celsius in 50 grams of water? So not 100 grams. Well, can I use my curve then if I'm not in 100 grams of water? The answer is no. This curve is for 100, but I can use it to help me. So how do I set up a problem like this? Well, we're talking about NaNO3, and it's at 10 degrees Celsius. Okay? So we found out that we know what's in 100 grams of water. So I'm going to set up a little proportion here. We know that 100 grams of water, that's this graph. That at 10 degrees Celsius, we just said 80 grams will dissolve. So 80 grams of the NaNO3 dissolve in 100 grams of water. Well, that's great. But this question asks not for 100, but 50 grams of water. So we're going to take that beaker of water and we're going to empty out half of it. Now how much solute will dissolve? So that's X. how much will dissolve in 50 grams? 80 dissolves in 100, how much dissolves in 50? So in this instance, all I have to do is cross multiply. 100 grams times the x equals 50 grams times that 80 grams, divide by the 100 grams, and solve for my x. Well, hopefully you're looking at this and saying, well, half of 100 is 50, so half of 80 is going to be 40. So your x is equal to 40 grams, half the amount of solute. So 40 grams is your answer. Setting up proportions is a really easy way to solve these problems. That's the end of the video.